This is almost a self-running working group anyway.
Almost. But only the true chairs have certain magic powers.
Yeah, I'm not really sure what those magic powers are.
Or to declare consensus,
Oh, is that what it is?
pretty much.
I declare consensus that, I don't know what.
Okay, well, that's not a word used for consensus.
It's the most useful.
Power, here's my ass. There's power.
Wow, that's really impressive to be a dabble jabber strike. I mean, that's like double
Sure.
redundant. Dabble and jabber mean the same thing.
We could probably run one sort of over the
Oh,
other.
thanks. Julius isn't here, so we can't start.
Other way around.
I'm not too sure about that.
Just the word minimum.
We could do something exciting like introduce ourselves.
Dabble and jabber.
Well, is it pretty long?
And Harvest members in the general. Somewhere.
Is that in your debit card?
I can.
That's a church job too, trying to find volunteers, right?
So this is on the grind. You can walk you out behind us. How did you do this?
Let me check.
Probably will, perhaps. What is that? Or the whole time.
I don't like these
But it's got less to do.
where everything goes on the screen.
Let's see. Open all of these. That's fine.
You got my updated slides, Tom?
Hmm?
You got my updated slides? You want to go?
Oh, we're not. I don't know.
Get in your email.
I'm sure. I can get them in real time, probably.
Just next to my slides.
Oh, yeah, so definitely the projector turned off.
That's okay, we can see it. They don't need to see, just turn the monitor on.
Maybe. I'm not sure. So this seems actually unusual that there's no remote people. Whatever.
Is there no vote?
Well, I guess there are, sorry. Yeah, there are people.
There
Sorry.
are five on the.
Yeah,
Yeah.
on the-
it's hard to see from here.
There's a lovely conversation about trains on Chapter
Okay.
and about Julius turning the rubber.
Why would Julius tell me about it? Can you say tell me?
Please don't.
Got lost.
I mean,
Yeah, I feel a little silly.
Well,
I might do that, I might do that if I was gonna present something that people might throw rotten tomatoes at me for.
I mean, I've got the meetings where there was like a big head table, and people around the table, some of them joined the meeting remotely,
I mean, we're.
so they could have it on the screen right in front of them, way down there.
Yeah, that's true.
You know.
Julius, we heard you were joining remotely from your hotel room.
No, I'm actually joining remotely from downstairs.
Okay, that's fine. That's fine. Fine.
Let it get moved.
Let's see. I guess we're a couple minutes late. Here, so we should be going.
Hear ye, hear ye, hear ye. We officially start.
That's a good microphone.
Welcome to Babel. So what's our agenda to start with? We're going to start with, I'm Russ White. I'm a routing geek.
And I'm not at least like, I don't know, I'm a bureaucrat. No, I don't know.
They do this on purpose. They have one.
Oh, so this slide is wrong.
Oh, it's Martin now, right? All right. So we now have a new AD, Martin. Is Martin's here? Martin's here. Martin.
Everybody trusts this working group so much.
Yeah. You can tell we're a very heavy, hard-working working group that does all sorts of. I was going to comment at the routing area open meeting that they seem to have given you all the non-controversial working groups. Was that intentional?
I don't know. I don't know if it's in the discussion on thing.
Oh well, that's right, spring. But I heard spring was closing. No.
Anyway, this is the new Notewell, which you should note. It's got pointers, and actually, the BCP appears twice here because it sort of referencing parts of it, two different parts of it. So people should review documents. It's great. So this is a proposed agenda. So there's 3 presentations, and Dennis also wants to just have a couple minutes to talk about the revised RC he's working on.
Bash, anybody have any changes?
People have topics they want to add or delete? Yeah, right. So so that's sort of related to security, maybe after the DTLS, I don't know, whatever. Sometime we can slip a few minutes in for you if we keep on schedule. Let's see. We're not behind schedule yet, so. And anyway, so just quickly review status. We've got these. I guess there's I don't have your draft on here. I just have 6126 bis, but I didn't update this recently. Anyway, there's these are working group adopted drafts. So the HomeNet draft, and I guess it doesn't have any personal drafts on here except for the Ted Lemon HomeNet draft, and of course there's the original set of RFC. So I guess there's a 7298 bis, right? Yeah. So that's also maybe on a list of personal drafts next time. So we're kind of behind on our milestones. So not too much to say about that. Possibly we should revise the milestones to get them back in sync where we think the working group really is, but we can do that offline and stuff. I don't have any proposal for changing the milestones currently or anything. So if people are okay with the agenda, yeah.
Julius Krobachek, what's happening with source specific?
What
I'm
happened?
not clear on what we should do about source specific now. As far as I can tell, there is consensus.
Okay.
There is consensus for the source specific draft, and I'm asking the group what I should do next.
What status is it in? I don't know. Did we do a working group last call on it?
No.
Okay. Well, I guess what you should do is ask for a working group last call.
Can I do it now?
Since, sure.
Okay. I'd like to ask for working group last call for source specific.
Okay. I think it's been around for a while and it's been discussed, and so I will.
Implemented, right?
So, yeah.
Implementation.
Right.
Yeah. So
Yeah. There's
we can do less call.
there are implementations. So it's of course sort of based on 6126 bis, which is sort of still in an extended working group last call, waiting to resolve the things that I believe. So I'll start to do that right after the meeting here. Any other interesting things people want to do or should we just proceed with the update on the bird implementation status of Babel? Sounds good. Actually, let's see here.
That is a very interesting way for a microphone to be pointed.
So
So
this is what I have. You want me to are there, so you say in my mail, which,
We'll drop this on the floor when you find this.
That's fine.
okay. Is that, oh, sure, that looks like a good one. Inbox.
This is a very small pink box.
So, I'll be down here, I guess. We will. So, I assume this is pretty close to what is online.
Yes.
So, I'll just go ahead and use. Yes, and if you give me the little gizmo out of it, you might be able to advance the slides. Okay, this is what you just sent me. Probably want to view the full screen version.
Yes. Can I get it on this screen as well?
Oh, I see. Well, I can see it. No, I'll hold. Hold on a second. Let me. So what I want to do here, I think, is just go to the.
Command F1.
Command F1. So actually, I just want to force them to be the same. There we go. There we go. So I now have only one display, so to speak. And it's higher resolution, looks like. There you go.
All right. And I can maybe, yes, I can do things.
Amazing.
All right. Awesome. Yes. Hello, everyone. My name is Toki Herland Jørgensen, and I am the author of the Bird implementation of Babel. And I am going to give you a short update on the status of this implementation, since it's been a while since you've been forced to listen to me. Quick recap for those who don't know what the Bird routing daemon is. So it's a from-scratch implementation of a lot of major routing protocols. It already spoke BGP, OSPF, RIP, BDF, and RA, some of which you might notice are not actually routing protocols. But they were there as well, and I added Babel support to this a few years ago. It's a very nice implementation. It's a very nice daemon, clean code, well organized, readable, and the daemon itself is pretty scalable. There's no problems using this for a full BGP routing table, for example. So this seemed like a cool place to implement Babel. And of course, Bird is also developed by some friendly and very meticulous Czech people, which is really nice when you have them reviewing your code. And so I did the initial implementation in 2015 of Babel, and I did an implementation experience talk of this at the IETF 95 a few years ago. And at that point, there was no release that contained the Babel code, but that was first done in Bird 1.6 in April 2016. That was an implementation of the original RFC 6126 with no extensions, but because the 1.6 version of Bird is not dual stack, this was IPv6 only. It did interoperate with Babel-D. So since then, with the release of Bird 2.0 in December last year, we now finally have IPv4 support. Yay! Yes, just in time for the end of the 20th century, plus minus a few decades. So this is not actually speaking Babel over v4, but this carries the v4 routes over the v6 packets, just as Babel-D does. And it does that in a way that interoperates with the original Babel-D implementation as well. And then there's been a few updates since then, as we've been working with RFC 6126 BIS. So we've added sub-TLV parsing, and we now honor the mandatory bit as well, and discard all mandatory sub-TLVs that we don't know, which is basically all of them, with one exception. We also it's also learned about hello flags, and we also will cheerfully now discard unicast hellos. And so this was the thing that I had to revise my slides, because the nice people over at Bird headquarters, as you can see, released a new version just a few hours ago. So before, this was on the list of non-released features, but that means that there's now a released version of the Bird routing daemon that speaks source-specific routing from the updated draft. So that is the implementation of Babel source-specific 03, which means that it will speak to the Git version of BabelD, but since the encoding has changed, does not interoperate with the legacy version. So unfortunately for people who already run source-specific routing, a flag day is needed, but that was going to be the case anyway. And as you can see, it's source-specific routing itself is pretty easy to implement in the core protocol. It's less than 200 lines of code. I'm cheating a little bit here because, of course, that requires the kernel to know source-specific routing, to know what to do with them, and this does not count the Bird core changes to support source-specific routing either, which is another 200 lines of code or so. So all in all, it's not that much, and it's pretty useful to have source-specific routing, so that's nice. Then there's a few additional unreleased changes which have not been accepted upstream yet. One of them is the acknowledged retractions optional algorithm that was added in IRC 6126-BIS, also known as the Chowan algorithm. That is pending code review. It's actually about the same amount of code as source-specific routing. But it's pretty neat because what it does is that when a route goes away, instead of having to wait for the whole time, which should be several minutes, we can now remove the black hole almost immediately, since we get retractions from other peers. And then I have been playing around with unicast stuff, but I got stuck somewhere around. So that is only on my laptop, and I will not show it to you. And then looking further ahead, obviously I've plans to experiment some more with the unicast stuff. I also have some plans to do the security depending on the next talk and what we end up deciding there. Tentatively, there's HMAC support already in Bird, so I was probably going to start with that, but we'll see where we end up in the discussion. And then there's also the whole Wi-Fi issue with, it would be really neat to be able to get some parameters out of the kernel and do something useful with that, instead of just doing the multicast hack where we look for drop packets. And of course, scaling packet transmissions. I think it would be really fun to try to dump a full BGP routing table into Babel and see what happens. Those sorts of things. And of course, this is not a promise to implement features or do any work or anything whatsoever. This is just ideas at this point, and if anyone else wants to implement some of it, please do. That would be cool. So just to sum up, we have a full IRC 6126-BIS implementation in Bird 2.0. It's interoperable with the deployed BabelD except for the source-specific. Oh, bugger, I forgot to update this. This should say 2.0.2 and not Git. Sorry about that. Which does not interoperate with BabelD, but it does interoperate with the upcoming BabelD, which Julius will release anytime now. And security and unicast work is pending. So please test, report back, patches also welcome, and so on and so forth.
Okay, one question, Russ White, LinkedIn, no chair hat on. This is kind of a technical question maybe. So you're carrying V4 routes over the V6 transport. How does the Bird, how does Bird interact with the RIB in terms of next hops for V4? Just curious.
That's the next hop TLB.
Okay, but I'm asking, like, does it check to make sure the V4 next hop exists before it tries to install, or does it try to install and then it just fails if there's no V4 next hop, or how was that something that you had to deal with? If so, I'm curious how you did.
That's a good question.
Okay.
I don't recall offhand. I don't think it's doing something terribly intelligent about that. I'll check.
Okay. Cool. Thanks.
Yes.
Tony P. Juniper. So first question is, has been done on the Linux kernel for the source destination specific lookup?
What do you mean been done with?
I mean, like you said, Babel is fantastic for the stuff. You get all the source destination stuff, but now you need the lookup support in the kernel, right, to push it in.
Yes, that has
So
been.
did they do any work, serious work in this respect?
That has been supported in the Linux kernel for several years. For V6.
Okay, excellent.
Yes.
For V6. Okay,
Yes.
excellent. So I just left this
So
information.
for V4, you can implement it using policy routing, but that is not implemented. But there's native support for it in the Linux kernel since at least version 4.
Okay, so I go look at it. And then obviously, since you ran out of ideas for 200 lines patches, you shall implement beer, right? And we actually have the completely native V6 encoding on the plate, so you can run the whole beer in user space without any kernel support, right? So it's like hop by hop, link local to link local, and you get the full frame, and you can do whatever you want, and then push it further out.
Yes, I will.
Okay.
I will put that on my list of ideas. I
200
haven't
lines,
quite.
maybe 210. Maybe you edit or may crash. So.
David,
Yes, please send a patch for beer support. I would be happy to look at it.
channeling Marcus Stenberg, who said that source-specific routing has been in Linux for 4 years, and 90% of it, there's some slight bugs on slight edge cases, but in general, it's been there for 4 years.
Yes. All right.
All right.
Okay, Julius Krobachek, just that means that you have, as far as I can tell, you're fully compliant with 6126 bis as it currently stands, and you can implement the Babel profile for HomeNet.
Probably.
Except perhaps for link quality estimation. Do you do it? Yes, you do. On Wi-Fi.
What do you mean link quality?
You do ETX.
Yes.
Okay.
All right.
Okay.
Okay, it's working,
Yeah.
I think.
You want to control? We can move this slides forward and backward with that.
Well, hello, I'm Antonin Desimo, and I'm going to present a joint work with Julius Krobachek about securing Babel with DTLS. So we need security in Babel, and for that we have two approaches. Either we could secure the lower layer with protocols such as WPA, OpenVPN, or we could secure Babel in Babel or Babel in Babel with two approaches also. So Babel HMAC cryptographic authentication or DTLS. DTLS is the transport layer security adapted to work on UDP on datagrams. And this is the subject of this talk. Why DTLS? So DTLS is a plus because we don't have to think about a new security protocol, and we don't have to implement it. It's someone else's problem. DTLS provides asymmetric keys and authentication and confidentiality. Okay, so good things. We have a working implementation. We use the embed TLS for our TLS implementations. So here you can see a screen capture, packet capture, I mean. We have neighbor discovery packets in blue, then a DTLS handshake starting, and after the completion of the handshake, the two Babel peers exchange Babel protected data in green. This is, for the moment, the user interface. So you have to say that you want to use unicast on the interface. Then you want to enable DTLS on the interface, and you just give to Babel a link to your certificate, the private key, and eventually optionally the CA certificate and the key, the password to the private key. Okay, so Babel is based on UDP. You can use Babel over unicast and multicast, and Babel is a peer pure peer-to-peer protocol. It means, it means that the same port is used for source and for destination. And Babel-D, the implementation, the reference implementation of Babel, uses a lot of multicast, but DTLS can only protect unicast. So Julius had to rewrite the buffering mechanism in Babel-D from a lot of multicast to unicast. In the implementation, unicast is independent from DTLS, and now we can protect Babel. So it means that the routing information is protected, but neighbor discovery packets, so hellos and link quality estimation packets, so hellos and IRGs remain unprotected. Okay, now I'm going to talk about our current prototype. So in DTLS, the handshake is asymmetric, but Babel is purely symmetric, and we have to break that symmetry. So we use the classic technique of selecting the lowest link layer address, the peer with the lower link layer address, and it becomes the DTLS server, handshake server. Now, when we receive a packet, so the Babel structure is pure peer-to-peer. We would like to preserve this with DTLS. So we choose to receive all traffic from Babel and from DTLS on the same socket. But we have now to differentiate packets coming from DTLS and coming from Babel. And it turns out that the DTLS library can do that for us most of the time. So we have to, so we receive the packets from on the same socket, and we try to decrypt the packets. So we give the packet to the TLS library, and if we succeed to decrypt the packet, we tag the packet as secure, and if we fail, we tag the packet as insecure. If the packet is insecure, we will ignore all TLVs except hellos and IHU. So we either way we pass the packet. As an optimization, multicast is insecure by default because DTLS cannot protect multicast. And this behavior is interleaved with the DTLS handshake, meaning that while we are processing a DTLS handshake, we can still receive raw Babel packets. When we emit a packet, we say that all unicast packets are protected. So we never send a unicast packet that isn't protected by DTLS. And all multicast packets are sent in the clear, but we only send hello and IRG TLVs by multicast. Of course, there are other approaches. We could use a pure peer-to-peer on another port. So we would have one port for Babel and one port for DTLS traffic. We could use a classic client-server model, or embed DTLS into a embed DTLS data into a sub TLV. So clearly, this is not a serious proposal. David is laughing, Julius, they are laughing, okay. But we have two bits of disagreement. Should the server port be the same as the Babel port? And should the client port be the same as the server port? We need to discuss that. And we still have some open questions. So is passing insecure packets really a good idea? And another question was raised on the list. What if a peer reboots after a successful DTLS handshake? So it turns out that there is a section in the DTLS RFC telling us what we should do, but most implementations don't do this. We could use different ports, or we could do a bit of hacking in the client or in DTLS library. There is room for other internships here. Also, on the usability of Babel-D, how should we deploy keys and certificates and roll the invalidate keys or rollover? And another question, will the DTLS overhead cause fragmentation, especially when exchanging certificates and keys? So good news, Babel can be protected by DTLS. We have running implementations that protects data, but not discovery. And hopefully it will be available soon in Babel-D. Thank you for your attention.
So Tony P again, from long experience with IGPs. So key management, still it's straight out from the IGP protocols. And yes, it's manual, it's a rollover. They went through all this operational stuff. I mean, it's well understood what ultimately customer deploys, right? The most common attack is really replace. Mm-hmm. I do not protect against that at all. because DTLS doesn't give you any nonces or anything like that, I assume, right? So it does. So DTLS does already the replay protection. So what's the reason about this adjacency formation? It's just because multicast and that you don't know how to encrypt multicast? I mean, you can put something and encrypt that stuff, even a small piece of information on this key, and it will give you, at least you know that it's the right guy sending. Because the most common attack was really like replay protection, especially on the adjacencies, which most often ended up just being a denial of service, right? Because they weren't able to like get the adjacency fully up, but you can actually muck things up pretty badly with simple replay attacks. So just practical experience.
David Skenazy, Apple. To answer to Tony, so DTLS gives us replay protections amongst a bunch of other properties, but indeed, if we don't do anything to protect the hellos, the attack on Babel is, so you can send evil hellos and mess up the sequence number counts, which will completely mess up your link estimation, and you could also replay them, which would probably have the same effect, actually. But that's, that's it about DTLS. So, another.
Hello, my name is Dennis, and I've been waiting for this for about 2 years, the DTLS mechanism, because Illush had advertised it since 2016, and I've been asking the same question. Is it possible to see a document that explains how things are expected to work? For instance, like security considerations, the bad things that you see might be happening, and how you see the mechanism is protecting the main instance of the routing protocol from those bad things you see. And I didn't have the opportunity to see a document that would explain it. It's nice work in progress, okay? I'm not saying you're doing a bad thing, but what I'm saying, there should be a document that explains what you meant to achieve, such that if what you're doing is not what you wanted to do, other people can see it and say, that's what you're going to do, that's what you have actually done. So if this can be fixed, then we need to fix it. Otherwise, we should review the assessment of the security threat and say that, no, that's not the model that should be. It should be different, then the implementation should be different. So in a normal development process, things go forth and back, such that you build, then you look what you have, then you get back to the specification, proofread it once again, and you need to have a document so that you have a thing to discuss and to say that this is what you have missed, this is what's done right. And in that document, it would be nice to have a section that spells exactly how many bytes do you introduce as an overhead to the main protocol. Because there should be some overhead. It would be nice to know how much it is, like 5%, 50% of the normal traffic.
I think we have to do some testing.
It's one of the things that needs to be discussed, because when you hit a specific implementation that can do only those many bytes on the wire, because that's the type of link that you have, then you need to see if the protocol can still work on that link.
Okay.
Thank you.
So I always wanted, this is Donald Eastlake with Huawei. I just wanted to say that such a document seems like a great thing to have. And it just mentioning on unicast and multicast, I mean, the DTLS has a thing where it does this handshake to generate the keys. So it's sort of inherently peer-to-peer kind of thing, point to point. And, sort of the natural, you could easily build something which is multicast, but has some kind of group key.
Okay.
But it's easier to do that securely if you want to have a group key of something like that. If you have some way to distribute that key to the group members, so you kind of want to have a point-to-point security already set up. But the funny thing where you most need the multicast is where you're first discovering people and stuff like that. So it's a little bit of a chicken and egg kind of problem. So anyway, I just wanted to say that.
Okay.
Julius Krobachek. So I'd first like to answer Dennis's objection. There was no intention to exclude anyone by not writing things down. So actually, the two implementations happened last week. Okay, so Antonin finished 2 weeks ago. Correct? When did the packets pass? It was a Sunday, I remember.
Yes,
But
yes.
I don't remember whether it was last Sunday or the Sunday before that.
2 weeks before.
As to David, he finished 10 days ago, I believe. So first I would like to point out that, there is on one side Antonin and on the other side a multi-billion corporation, and Antonin finished first.
Yep.
And the other point is that it is really very, very recent stuff, and we simply haven't written anything down yet. Okay. And so the second point is that I'd like to make is about the first slide, if you can show it back. Oh, the second slide. So what we now have are two extensions to Babel for cryptographic security, and they are very different. So HMAC is simple, makes no other requirements, and has minimal and does symmetric keying only with a shared key for everyone, only does authentication, no encryption, no privacy, and protects everything, including multicast, and requires very little changes to your Babel implementation. You're still doing Babel over multicast. Babel over DTLS is this work, and this thing makes you depend on a complex library that you don't understand, because nobody understands DTLS. But on the other hand, it means that crypto is somebody else's problem. So at some point, we're going to have to decide which we want to have as strongly recommended in the draft. And I would be in favor of pushing Babel HMAC with Babel over DTLS being the optional algorithm that is reserved for those environments in which you really don't want to have your own security stack, or you need the extra features.
You're saying that DTLS moves all the security to someplace else, but it's not clear to me that it seems to me you need to provide some protection against people screwing with hellos and I heard yous and stuff like that. And if DTLS doesn't do that, then it's, even though it may push the crypto off to somebody else, it may not. The crypto provided by this other party may not be what you need. So,
right. So there was one proposal for that. So my impression was that we're not protecting against DOS.
Yeah.
Okay. It looks like I was wrong. If we want to be protecting against DOS, then DTLS can work, I believe, thanks to the unicast hello extension that was recently done. But I think David has clearer ideas than I do on that subject. Is that?
Sure. Well, okay.
Tony P again. So I would, from practical standpoint, having played with the stuff for 20 years, right? I would second what Julius says. Replay protection plus something like SHA-1 for integrity is mostly as far as people go. And if you have something which is simple, doesn't precondition library, lots of overhead, computational overhead, this goes a long way. Where the world is going, the DTLS will give you a leg up, right? I mean, the security guys are coming down heavy. They're coming down heavy for a good reason, right? So I think you'll end up there anyway. But having DTLS as the only option, that's a fairly fat pick, yeah. If you want, like, practically deploy the protocol and be successful with it.
One thing I'd like to add, David Skenazy, Apple. DTLS doesn't just give you encryption on top of this. It does a new key exchange every time you set up a new association. And so that means that you will never have replay attacks or messages that could come on at a later date, or people sending traffic that they slightly modified. It has a much cleaner security boundary. And if you say that everything, like hellos are outside or hellos are, and I heard you are outside, and everything else is inside, you know that everything else is completely immune from replay attacks. Whereas with the HVAC work, Dennis found a very clever attack on it, which, because of the way it is, it's kind of harder to reason about and harder to make a security boundary. So it might have other attacks. I'm not a security expert, but it might have other problems as well. We could also, another option is to use a combination of both, where you could establish DTLS, use a key exporter, and use that to HMAC the hellos. And that gives you a very secure model that is also immune from DOS attacks. That's an option.
I think I'm going to cut the line after you. You go ahead. Yeah.
Yes. Okay. Toby Holland Jørgensen. So I like features as much as the next person, but I think from my point of view, having something like basically what Tony's at, having something that's really simple, doesn't give you all the security features, but does give you a barrier between, for me, the sort of the main thing that this security mechanism should provide is I run a network, I control the routers, I run Babel on the same links that there might be client machines, and the client machines that do not know the password cannot mess with the routing. Like that's sort of the simple use case. But we don't really have an agreement on what features we want. Like there's no threat model. I think so it's sort of a difficult discussion. But to me, at least, having the option of doing the simple thing would be important. And also from an implementation point of view, I would also like to have security available in environments where I can't have a DTLS library, such as on a tiny itty-bitty Linux router with 2 megabytes of flash.
So more input on that. So there is really this layering of what security is comprised of, right? So the SHA is like the simple integrity, if you want. Then you have the replay thing, and then you have really the what you call it, where you can see what's inside. It has a name.
Confidentiality.
Yeah, confidentiality, right? And you'll be shocked why people deployed OSPF HMAC. The one single most important reason was they didn't want, by misconfiguration, having random adjacency coming up. There was a protection against people misconfiguring the network. It had nothing to do with security. Okay? yeah, literally. Well, so the keys are hanging there for 20 years. And the only reason is you can't just randomly bring up adjacencies. And then,
because it's a really good error correction mechanism.
No, it's error correction and harder to misconfigure. And then the replay attacks were there, getting more common. And the confidentiality is something that has always overhead in the price. You have funky libraries, funky version of the libraries. You have to run funky tunnels. If you bring up IPsec tunnel, before you get this, the security association, it takes forever and then some, so the convergence slows down. And practically speaking, people don't do that, right? And then you think like, oh yeah, but then they really have a key infrastructure. No one ever deployed a dynamic key infrastructure on a routing protocol. And I built some, I have been paid for it. But then once people understood what is the implication that you literally break your network, right? If you lose the key authority, no one dared to flip it on, no matter how paranoid they were. And I dealt with some pretty paranoid people, including like the people who shoot missiles in the sky. Yeah.
So I'll say the other thing, with my chair hat off, I would get up and walk around, but Tony was blocking the microphone. You were very concise. Anyway, that's your job. Is that when I was at Cisco and we were testing HMAC MD5, and we decided to test performance, we determined that turning on encryption on routing protocols is actually an awesome way to open up a new security hole in your network, because most modern processors, even if you throw enough missigned garbage at them, it will take down the processor on the router. So you've opened yourself to a denial of service attack at very low packet rates, much lower than you might expect.
I think we really kind of have to move on to the next item. But
Okay, I just wanted to make a quick point about the point of disagreement on the ports. Could I make a quick
ports.
30-second
Okay,
point?
that's a different topic. Go ahead. Ports. Want to say something about the ports? Go
Yes.
ahead.
So, thank you. As Antonin pointed out, there are several ways we can do this. I just wanted to insist on the fact that I feel very strongly that we should have a separate port and randomized client ports.
Okay. In general, it is possible to get 2 port assignments for a protocol, one for sort of insecure and one for secure. That's one thing that the port, I guess it's the pool of experts that are for port assignments will allow 2 in that case. So it should, if we want to do that, we should be able to do it. So
yeah,
we need some more discussion on the list perhaps, but.
Yep. No, I just really wanted to point out that most implementations, we would be, if we use the same port, we'd be relying on something that, as far as I know, and I've asked a bunch of people in the TLS working group, no implementation exists that supports this. And having to go and change DTLS implementations is not something I'm comfortable doing.
Okay, so we got to move. Dennis wanted to talk briefly about 7298 BIS, and we do have another talk. So what do you want to say, Drew?
I just have a very quick that I believe that everything that David is speaking about can be done in the client, but that's a debate for another day.
Okay. Do you have okay? Anyway, thank you for your.
Thank you.
Okay, so you want to speak about 7298 BIS? Yeah. I mean, so you asked for a few minutes to do that, so go ahead.
Hello, I'm Dennis, and I'm here mostly to remind about my message in the working group mailing list. I have uploaded an individual internet draft that I believe addresses the problem that I had described a few times on the mailing list and on IETF 98, I think, session. I had slides that explained in as much detail as possible how the attack works, and we had a few threads. Now, I have updated the 7298 with a solution that I believe solves the problem, and because it's still an individual ID, I would like to propose it as a working group document, because as an individual ID, it's useless and it doesn't serve the purpose. If the working group is interested to pick it up, I can finish the document. At the moment, it contains the essential parts, the technical description. Then it needs some generic changes. I can do them if it becomes a working group document. If it doesn't become, then, well, I've got a lot of other things to do. So I'm mainly drawing your attention to what I believe to be an adoption call, right? What's the formal term for it?
If there's anybody who objects to issuing a call for working group adoption, they should speak up. Otherwise, we'll do a call and, see what people say. And unless there's objections, we'll probably adopt it.
I had explained the attack in detail before. If anybody wants to discuss, I can discuss. I can explain how the solution works. But if you want to talk about, I would reasonably expect people to read what I have written, maybe together with me. We can run through the document, and then you can have your opinion if it actually solves the problem or if it doesn't. But I think it does. Regarding the point that we discussed 5 minutes ago about control plane protection with the computational intensive operations hitting the central processor on the device, right? In 7298 original, there are provisions that address that specific problem. They try to keep CPU load as low as possible when the attacker just feeds packets that pretend to be integrity protected. That's it. So that there is a mitigation already in that document for that problem. That's it.
Okay, thank you. I think we'll issue a call on the mailing list for working group adoption of the 7298 BIS draft. Next is Babel information model.
Alrighty, so it's been a while since we actually discussed this, and I know y'all are all really excited about it. But anyway, this is just a brief structural overview of what's in the current draft. But Julius and I met on Monday, and then I internalized our meeting on Tuesday, and then we talked again on Tuesday. And so there's a lot that's going to be changing, but it's still mostly this. It's just not quite, but anyway, that's what it was. Now, one thing that we are going to get into, I just put this slide just to compile a list so people have a warm, fuzzy feeling that they know what actually would be configurable from the data model as opposed to just readable. And it's just that it may be configurable because it is up to the implementation to decide whether or not to expose something as configurable or even to make it configurable to some people, but not others. There are changes coming in the O2 version. Yeah, there's a lot of nits that are fixing. I'm adding an appendix that's going to have the change log so you can see what all the changes are, but just some kind of big things. Yeah, that's not really big. Yeah, we are adding a Babel link type, taking away this lossy link, and so we'll be able to expand it as an enumeration as other link types become supported in implementations, for example, Powerline coax. We still need to work some on the Babel security object, but in any case, I'm allowing for credentials, multiple credentials of one's own in addition to multiple credentials of NCA credentials and things like that, just in the description. But, how a security mechanism makes use of these credential lists is up to that security technology. We're going to add some route filtering rules, a table for that. That'll be optional to support a security log, just to record anytime when you actually examine credentials. And yeah, there's some other things. We're going to get rid of the source table. Anyway, that's just a summary. I hope this is readable and I didn't make it too small. I'm really sorry, but there's some open issues. I'm not going to step through them all. Y'all can read through them and tell me if there's any that stand out at you, but I'd be curious. I think one of the, let's see, at the end, oh yeah, this was number 8. This was all based on input from Julius, so it reflects his implementation. We really need input from other implementers. Okay, and just so you understand, it is structured that a lot of the data model parameters are listed as optional, and that is because if an implementation does not support these, if it's not something that in how that implementation is designed, that's perfectly okay. You don't have to support or implement the parameters either, even if you choose to implement the information model via some data model. So that's kind of what optional means. It means, well, optional.
Amazing.
Huh?
Amazing.
I know, right? It does not mean should. That's a totally different word. Okay. Nothing? Nothing? Okay.
Okay.
That was it.
Okay. Well.
Okay, then I'll say something. Julius Krobacek. So one thing that users do want to configure is filtering rules. And the three main implementations, open source implementations of Babel have very different configuration languages for filtering. And I don't think it is our job here to extract a common filtering language from free-range routing, Bird, and my homebrew implementation. Okay, and I don't know what to do about that. And I would say to leave the filtering rules as an OPAC object.
So I'll say, Russ, LinkedIn, chair hat off. that it is not your job to bother with trying to mess with the filtering rules. It's whatever is in the implementation that you're using, Bird, free range routing, whatever, because the users of those implementations are going to expect them to be the way they are for BGP, OSPF, ISIS, whatever.
So we had discussed that I would just put a proposal in and see, if people like it, we can have it, as to how to model really basic filtering. And if something does more advanced filtering than really, really basic stuff, then it's just not in the model and it's not configurable via that model, and they would have to do custom model elements. Or we could do nothing about filtering, either way. But I can propose it and you can see it and throw up all over it, and then we take it out.
I'm very afraid that if we start doing filtering rules, then we will end up adding features and never finishing.
I guess I have a question. Would it make any sense to have sort of an opaque block of stuff which only something that understood that implementation could parse, but could be obtainable through the whatever method you had of reading out the configuration, with your management protocol?
Say that again.
Just have an opaque blob of filtering rule stuff that you could obtain through your whatever management protocol you were using, but you'd only be able to understand if you understood that implementation.
Honestly, it makes more sense to suggest that an implementation create custom parameters for their implementation if they want to expose it.
And they extend the model.
Yes.
Okay, that's probably true. So that was completely off the top of my head. Okay. So does anybody have anything else for this meeting, I guess? Do you have anything you want to say? No? I guess not. So see people on the mailing list, and oh, wait a sec, sorry. I'm too fast here. Go ahead.
Hi, Roland Valtino. Not to throw a spanner in the works, but I read the source-specific extension a while back, and it's a very short document, especially if you leave off all the boilerplate. And on each page of the remaining document were about 3 or 4 references to the 6126 document. I was wondering, would it not be simpler to just merge the two things?
What? Well, that's so, yeah.
Just a suggestion for your consideration.
Sure. Well, no, it's really for the working group's consideration. I mean, we can merge documents or split documents. I don't know. I mean,
David Skenazy, Apple. I would prefer them to stay separate, precisely because it's an optional feature, and in that case, I would kind of say you implement one RFC, gives you the main Babel, and then every extension to Babel is its own RFC. That seems natural to me. And also the timelines might not align exactly in terms of when we want to publish both documents.
Toby Harlan Jarensen. Yeah, same point, but I would add that you don't always have a forwarding plane that can handle source-specific routing. So if we added it to the main document, we would have to make it optional, and I think that could add as much text now than the back references from the extension does. And I think that having the documents be really short is a feature. It's it's one of my main my favorite things about this working group is the short length of the documents.
The thing is the readability of the extension draft or RFC as it's going to be. If you have to go back and forth to the main document all the time. That was my reason for suggesting it.
Okay, anybody have any other topics or points they want to bring up? Or we have 1 minute left, maybe. I guess not. Anyway, I guess we are adjourned in that case. Thank you all for joining.
See you on the list.
Yeah.
We're expecting you to push the new version in 15 minutes, Julius. Now that you're done with the working group.
Yeah.
The Babel